is structure and naming of amino acids. Okay, so up till now I think this is already covered. You know the names of major amino acids, like 21 amino acids, and they are categorized into 4 categories. One is uncharged, non-polar, uncharged, polar, aromatic, basic, and acidic amino acids. Okay, and you have to learn the names of each category with the specific structures they have. Okay, the only difference in the amino acid structure is their R group. Okay, as we know, other 3 groups are common. Common groups are NH3, COO negative, which is carboxyl group, and hydrogen. The group which varies the most or alters the properties are R group, and this R group has 4 different categories. That's why we learn them. Okay, so let's start with the first topic. Okay, I'll go ahead and explain from the starting. Hopefully I think I'm visible, so as the slides or notes, whatever you call. So if you see, this is general structure of amino acids, and this is called alpha amino acids because the functional group, which we call is carboxyl group, is attached directly with the carbon. Okay, that's why with this carbon is called alpha carbon, and this whole amino acid is called alpha amino acids. There could be other type of amino acids like alpha, beta, and gamma. Okay, but based on the other classifications we have, if you see, this is the functional group, which is carboxyl group. This is something new, but I just want to go through the pace. Okay, so this is the functional group, which is carboxyl. The carbon attached to the functional group is called alpha carbon. Okay, and that's why this type of amino acids are known as alpha amino acids. If you see this functional group attached to carbon, this is alpha carbon. Okay, and this carbon is called beta carbon, and amino group attached with beta carbon, that's why this is called beta amino acids. So we call alpha amino acids because the amino group is attached to the alpha carbon. If this is the amine group. Okay, and if this amine group is attached to the carbon next to alpha carbon, this will be called as beta amino acids. Similarly, if you say gamma amino acids, that means basically this is the functional group, which is carboxyl group. Attached to the carbon is alpha carbon, next carbon would be beta carbon, and the next would be gamma carbon, and that's why this amino acid is called gamma amino acids. Okay, anyway, I just told you about why we call this acid as alpha amino acids. Most of the polypeptide we have in our body is alpha amino acids. Okay, but there could be other forms of amino acids. um, there's the other topic, which is stereoisomerism. Stereoisomerism comes from the initial word isomerism. Isomers are basically same molecular formula but different structures, or maybe different optical properties, physical or chemical properties. Okay, but basically they have similar molecular formula. So this is called non-superimposable mirror images. So if you see amino acids like L amino acids, they have 4 functional groups, but they are attached in a different way. Okay, so in 3D space, if you have carbon here, you have 4 functional groups attached with that. Okay, and these are not mirror images to each other. So if you see your left hand on your right hand, this is not mirror image to each other. Okay, if you place a mirror, you will see this is a mirror image. Okay, but are these mirror images superimposable? The word superimposable means if you place one after the other, is it all overlapping completely? No. So this we can call is non superimposable mirror images. Okay, these are mirror images, but they are not superimposable. That's why they are called enantiomers. Okay, if I take these 2 images and flip it like this is completely superimposable, right? So non-superimposable mirrors are images are enantiomers. That's what amino acids are. These are mostly optical properties of isomers, but they are categorized under enantiomers for explanation. Except for glycine. Glycine is an exception. Why? Because the R group in glycine is simply H, which is hydrogen, and that's why this doesn't make sense. Okay, so they are not 4 functional groups anymore, because if you see glycine or structure of glycine, Glycine is carbon, hydrogen, hydrogen, NH3 plus, and C double O negative. And these two groups are basically same. So that's why this carbon is not alpha carbon, and this is not optically active. So if you've been asked a question that name an amino acid which is not optically active, your answer will be glycine. The reason is because it has a hydrogen in place of R, which makes them different from all other amino acids in the category. Okay. So if I ask you a question, name a optically inactive amino acid, your answer would be glycine. I would ask another questions regarding to that. Simplest amino acid in the whole category is glycine because it has a edge. Second simplest would be alanine because it has a CH3. Any sulfur containing amino acid? Methionine is a good example. Any other example on the side? Name two sulfur containing amino acids. One is methionine and the other is cysteine. Cysteine and methionine are two sulfur containing amino acids. Any aromatic amino acids that has a benzene ring? Phenylalanine is a good example. Tyrosine is another good example. And tryptophan is another good example. Okay, so three aromatic amino acids. So we'll understand about all those categories in the next part, which is called classification of amino acids. So I don't know whether you remember all those amino acids of different category, but I have few mnemonics to teach you how you can remember the names of the amino acids. Okay, the first category of amino acid is aliphatic nonpolar groups. Okay, and aliphatic nonpolar groups are glycine, isoleucine, leucine, valine, methionine, and then uh, alanine, proline, and leucine. Okay, so the mnemonic is to give me apple. Okay, if you are an Apple fan, then they have launched a new seminar with all this iOS 26 or whatever they call. So this is how you can remember the names of different groups, which is give me apple, where G stands for glycine, I for isoleucine, V for valine, M for methionine, A for alanine, P for proline, and L for leucine. Okay, can you repeat after me for once so that you can remember this well? So I'll start with G. G for I for V for M for A for P for L for. Can you remember this using this same mnemonic, which is give me apple? Can we go ahead and see the next part of the next category of the amino acids we have to learn, which is polar uncharged category, and this stands for cysteine, serine, threonine, asparagine, and glutamate. Okay, for now we are just remembering the names. In the next part we'll learn how to draw the structures of all those amino acids. Okay, so we'll go ahead step by step. First we'll learn the names, and second we'll learn the structures of those amino acids. Okay, the second part is I call you have to learn computer science if you want to make huge money, right? And huge money are tech companies: Apple, Google, Microsoft, Tesla, Nvidia, right? So if you want to make good money, you have to learn computer science. Okay, so if you want to work in Apple and Google, you have to learn computer science. That can lead to Apple and Google. So I say computer science to Apple and Google, where C stands for cysteine, S for T for, and then A for, and G for. Is that fine? I'll repeat one more time and then we'll move ahead with the next part. Okay, where C as for computer science, T for two, A and G for Apple and Google. Okay, I'll use Apple and Google most frequently to remember or keep everything uniform. Okay, so don't write C for computer in your exams. Okay, I'll be on target for that. But anyway, C for cysteine, S for T for threonine, A for, and G for. Okay, so I think we are done with this part. You can take pictures in between, I don't mind. The third part is aromatic amino acids. I told aromatic amino acid basically means you have a benzene ring which is giving aromaticity to the amino acid, right? And three amino acids you just have to remember, like I say I'm Indian, so I drink a lot of tea and I love tea. Okay, if you are here, like you can try chai latte or whatever. Chai is called chai in Hindi for tea. Okay, but anyway, so I say please try tea. Please for phenylalanine, T for tyrosine, and again T for tryptophan. Okay, don't say T. Okay, T for tryptophan and T for tyrosine. And I'll show you how, what a beautiful difference between tyrosine and phenylalanine with just a uh, OH group, which is hydroxyl group. Okay, so up to now we'll learn just the names and categories of those amino acids, and the next part we'll learn this about the structure. Okay, so I think I'm clear up to here. Can you repeat after me once for aromatic amino acids? P for phenylalanine, T for tyrosine, and T for, okay, PTT. It's for aromatic amino acids. I'll go again with Apple and Google. Negatively charged amino acids. Negatively charged amino acids are mm, aspartate and glutamate. Okay, I can say aspartic acid or glutamic acid if I remove the H plus from that. Okay, again Apple and Google, but this Apple and Google is not for asparagine and glutamine, but aspartic acid and glutamic acid. If you remember, aspartic acid, glutamic acid, those both are acidic, right? And acidic means they have negatively charged groups. Okay, so you have to understand those two part. Aspartic and glutamic acids are acidic amino acids or negatively charged amino acids. I'll move ahead with the last part, which is basic category. So there are 1, 2, 3, 4, 5 categories of amino acid. Okay, can you remember the first one? Aliphatic non-polar group. I said give me apple. G for glycine, I for isoleucine, V for M for methionine, and A for alanine, P for proline, and L for leucine. Okay, and second was polar aliphatic polar groups. Okay, and I said computer science to Apple and Google. C for cysteine, S for serine, T for threonine, computer science, and to Apple and Google. A for asparagine and G for glutamine. Okay, third category was aromatic amino acids, and I said please try T. P for phenylalanine, T for tyrosine, and again T for tryptophan. I tried fourth category, which is acidic one, aspartic acid and glutamic acid. Fourth category, basic one, and I have three. I called live happy and be alive. Okay, where L stands for lysine, H for histidine, and A for arginine. Okay, don't confuse with leucine, which was a part of the first category. Okay, this is lysine, histidine, and arginine. There are three basic amino acids out of 21. Okay, up to now I think you might have remembered the names of the amino acid with different category. Now let's move ahead and go with the structure of amino acid. Okay, so I think you can correlate this with the previous one. As I said, give me apple, which is glycine, isoleucine, valine, M for methionine, and then um, asparagine, proline, and leucine. Okay, but anyway, we'll see how these R groups are different and how you can remember the names of different R group. Okay, as I said before, the simplest amino acid of all categories are glycine. Okay, glycine is the simplest amino acid with the H. Second simplest would be alanine with a CH3. Okay, you can remember that easily. If you see valine, can you see valine is just inverted V? See that? Valine is just inverted V. If you have a visualization, good visualization, like it's like V is hanging the opposite way or upside down. Okay, and then fourth category is methionine. Okay, so methionine is a sulfur containing amino acid, and you can see number 4 is important to remember this methionine. As I see, there are 4 different atoms, 1, 2, 3, 4. Okay, and you can remember this as sulfur in the middle for methionine. Okay, there's no other way to remember this, but I think once you practice once or twice, you'll be definitely able to remember all the structures. Okay, the second category was no, I think I didn't finish the first one. Three others are remaining. I said number 4 is important. Okay, number 4 is important to remember the first category. Why number 4 is important? I would say 1, 2, 3, 4. Okay, again leucine 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, 1, 2, 3, 4. So most of the time you have 4 carbon atoms. Okay, one of them is replaced by sulfur in methionine, otherwise you have 4 different carbon atoms. Okay, that's why I say number 4 is important to remember the first part. Okay, am I clear up to here? Okay, let's go ahead and remember how we can remember the leucine. Okay, can you see a correlation between leucine and isoleucine? Yes or no? What is the difference? There's a word iso. Iso means isomers, exactly. So isoleucine is isomer of leucine. If you remember, I told isomers are nothing but they have maybe different arrangement of groups around the atom, right? So can you see this CH3 group, this CH3 group is moved over the first atom. If I draw this CH3 group has moved over this one to make this amino acid. Is it correct? Also one more time, this methyl group has moved to the first carbon, and that's why they are isomers of each other. Okay, I think you can remember this one. The last one is proline. Proline is a cyclic amino acid. You might face these questions sometime. Cyclic amino acid is proline. Okay, 1, 2, 3, 4. Again, number 4 is important. 1, 2, 3, 4 important. 1, 2, 3, 4 is important. Similarly, 1, 2, 3, 4 is important. Can you remember the names of and structures of those amino acids now? Yes, no? You have to, of course, practice. Okay, you have to practice, and definitely you will be able to remember. So I say number 4 is important for remembering the first category. Okay, I'll move ahead with the second part, which is computer science to Apple and Google, which is cysteine, serine, threonine, and then aspartic acid and glutamic acid, right? I think I have missed those two, but anyway. So cysteine is CH2SH, which is 1, 2, 3. That's why I say number 3 is important. Serine is sulfur replaced by oxygen. Okay, can you see the correlation? The sulfur is replaced by oxygen, and that's it. Okay, so imagine during course of evolution how nature played with atoms replacing one another to make a new amino acid. Okay, so this is how new amino acids are being formed during course of evolution, by replacing oxygen in this case with sulfur, or sulfur replaced by oxygen. Okay, so this is how new amino acids are formed, forming an isomer, changing the placement of CH3 group from one to the other place. Okay, anyway, I'll go to the last part, which is threonine. 3, threonine means 3, and I said number 3 is important to remember the second category. Okay, so 1, 2, 3. Okay, you remember group OH is important, and threonine is the only in this category having a OH. Okay, other are okay, and the other are left are asparagine and glutamine. Okay, the difference between aspartic acid and glutamic acid: the first one have one CH2 and the other one has two CH2. Okay, and that's it. Aspartic acid has one CH2 and glutamic has two, and that's the only difference they have. Okay, am I correct up to here? So yeah, this is the third category, and let's move on and understand the third category, which is aromatic amino acids. So I said aromatic means they must have a benzene ring, okay, which is C6H6. So if you simply add one important thing, they all have CH2 in common, so you don't have to remember that. Okay, all have CH2 in common, similarly as aspartic acid, asparagine and glutamine. Okay, got it? And then if you add just a benzene or phenyl group, It's called phenylalanine. Okay, let's understand why it's called phenylalanine. Okay, you generally call this group as pH in chemistry. You remember that? pH means phenyl. If you remove this part, what is the thing you have left? CH3. Is this alanine? That's why it's called phenylalanine. Understood? Alanine is CH3, right? Second simplest amino acid. And this one has phenyl group and alanine. That's why it's called phenylalanine. Okay. Second part is tyrosine. If you add OH group in the same part, you have phenylalanine. Correct? Sorry, you have tyrosine if you add additional OH group. So I say it differently. Okay. I said tyrosine is hydroxylated phenylalanine. Am I correct? Hydroxylated phenylalanine is tyrosine. So I can remember this phrase and also remember the functional group that has tyrosine additional to the phenylalanine. Okay. So you always remember this phrase or write it down. Tyrosine is hydroxylated phenylalanine. Hydroxylated means they additionally have a hydroxyl group in them. Okay. If you have questions, you can stop me in between. And I said number 4 is important to remember the names of amino acid, right? And the way I remember this is 1, 2, 3, 4. Number 4 is important, and in number 4 you have a nitrogen or a NH group. Okay, and you have this benzene ring over here. If you can draw this separately, it has a benzene ring here. See that? This group. So you have benzene ring in all three of them, and this is tryptophan. Tryptophan is one of the complex structure of amino acids you have to remember. Okay, but it's easy. Why? 1, 2, 3, 4. Fourth is NH, and there's a double bond parallel to the benzene ring. Okay, so you can like flip this benzene ring like this and draw it here, and then draw a parallel double bond next to this. Okay, and then 1, 2, 3, 4. Fourth is nitrogen or NH. That's how you can remember the structure of tryptophan. Tryptophan structure resembles very well with histidine. Okay, and we'll see how we can draw the structures of histidine as well. Fourth category is negatively charged amino acid. I said how to remember it. Live happy and alive, where L stands for lysine, histidine, and arginine. Okay, so again, I said number 4 is important. 4 is a very important number for today, right? Number 4 is important to understand amino acid structures. So I'll see 1, 2, 3, 4. Okay, 1, 2, 3, 4. 4 carbon. So 4 carbon, okay, is common in everyone. 4 carbon, 3 carbon, and 1. 4 carbon, 1, 2, 3, 4 carbon. So you see 4 carbon is common in all three of them. The only difference is they have 1 nitrogen, they have 2 nitrogen, and they have 3 nitrogen. Can you see the pattern? I always look for pattern to remember things. That's how you can easily hook that to your memory system. Okay, so I said 4 carbon, 1 nitrogen, 4 carbon, 2 nitrogen, and 4 carbon, 3 nitrogen. Okay, easy. 4 carbon in common plus 1 nitrogen means NH3. 3 carbon, can you see the structure? If you want to incorporate 3 nitrogen, you have to do it with a carbon, and that's why we keep carbon in the middle, so that you can incorporate 3 nitrogens around them. Okay, and this one is again you have to incorporate 2 nitrogens, one here, one over here, right? Simple. So you just have to remember this one, and this is very common. This structure is very similar to tryptophan. See that? But there is a difference, of course, because this has a benzene ring. This doesn't have a benzene ring. That's why they are not aromatic. Okay, and this has the tryptophan has double bond over here and here with a benzene ring. But this doesn't. This only have 3. Okay. So this is the only difference. You just have to remember, and they are basic. Negatively charged means they are basic. Basic means they have NH3, 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 or NH, or maybe this is NH plus. Okay. So this is how you remember. This is basic amino acid. The next we have left is negatively charged or acidic amino acids. Okay, we just have two, aspartic acid and glutamic acid, or aspartate or glutamate, Apple or Google. Okay, do you remember the asparagine and glutamine? Anyone who remember asparagine and glutamine? Asparagine has one CH2 and then CONH2. Remember, we have amide group in common, and then we have one CH2, and then glutamine we have two CH2 and then CONH2, which is amide group. Okay, if you don't remember, I'll go ahead and revise it once again. No, I don't have it here. Okay, I have it here. Can you see that it has one CH2 and this has two CH2? Okay, and then amide group. But this one has one CH2 and two CH2, but one CH2 and two CH2, but we have a hydroxyl group here. No, not hydroxyl, carboxyl group here. So that's why carboxyl means that's acidic group. So we have aspartic acid and glutamic acid has one CH2 and two CH2. As far as I know, I covered all the amino acid with the structures and names. Am I clear up to here? Yes, no? Now, can you have a look and now figure out, like, you remember the name and structure of amino acids? I'll go one more time and then we'll go ahead. Okay. So the first is, can you remember this? What's the mnemonic we have used? Give me apple, right? G for, I for, come on, you have to speak up. This is how you remember. Otherwise, you have quiz today and on Sunday, and you will face those questions for sure. So let's repeat after me. No harm. Okay. $0 investment, free memory system. Okay. G for, I for, V for valine, M for methionine or methionine, A for apple, no, A for alanine, P for proline, and L for leucine. Okay, did you get that? Give me apple. If you don't have written those mnemonics, you can do that. Next part was computer science to Apple and Google again, right? Remember that? And I said, oh, anyway, we have aromatic in the slides. Okay, aromatic had three. Please try T. P for phenylalanine. Why this is called phenylalanine? It has a phenyl group, and CH3 is for alanine. Tyrosine is hydroxylated phenylalanine. Okay, and it has an additional hydroxyl group. The third is tryptophan. Easy to remember. You have a benzene ring here, and 1, 2, 3, fourth position has nitrogen. Okay, and there's a double bond parallel to the benzene. Okay, the third category was polar uncharged groups. I said computer science to Apple and Google. C for cysteine, S for T for threonine. Okay, and then A for asparagine and G for glutamine. Okay, do you remember the difference between asparagine and glutamine? It has one CH2 and other has two CH2. And I said number 3 is important to remember the names of the other 3, right? Because 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, can you see cysteine has a sulfur group? So can we cover cysteine and methionine as a sulfur containing amino acids? There are only two having sulfur, is cysteine and methionine. Okay, anyone who knows amino acid having a selenium in place of sulfur? Maybe what's the sulfur containing as amino acid here? Cysteine. So if you replace sulfur with selenium, it will be selenocysteine. Have you heard of this name before? This is 22nd amino acid. We have 24, 26, but you just have to remember 21. This is a major part of amino acids we have. Okay, but if you replace sulfur with selenium, it will be selenocysteine. This is how nature plays with amino acids, evolving anew by replacing some of the other atoms which is already pre-existing. Okay, but anyway, we remember this is another category. The next was acidic and basic. Basic, I said live happy and alive. Al for lysine, happy for histidine, and alive for arginine. 4 carbon, 1 nitrogen, 4 carbon, 2 nitrogen, 4 carbon, 3 nitrogen. Okay, Next part was aspartate or glutamate, or aspartic acid or glutamic acid. One has one CH2 and the other has two CH2. As simple as that. Okay, am I clear up to here? Any questions? No. Ionization of amino acids, it's very simple. You have carboxyl group. Carboxyl group has additional hydrogen. When it dissociates, it's formed into carboxylate group, carboxylate ion, and a hydronium ion, or H plus. H plus will again combine with water to form hydronium ion. Okay, and that's where all the acidity comes, all the acidic strength comes from. Okay, as we say, pH is equal to negative log of H plus, which basically means more H plus you have, less is your pH, and more is the pH or acidic strength. Okay, you understand that part? We'll solve few numericals based on those equations. Okay, and basicity or basic property comes from this NH4 plus, that might goes to the by losing one hydrogen to NH3 plus H plus. Okay, it's common. And Zwitter ion, anyone who can define Zwitter ion for me, please? Zwitter ion. Okay, it's called Zwitter ion. Okay, and you remember at what pH we can see Zwitter ion? 7 is the correct answer. So basically at Zwitter ion, amino acid is electrically neutral. As you said, you have a positive charge and negative charge at the same time. Okay, so Zwitter ion is have zero charge at isoelectric point, which is 7, right? pH 7 is isoelectric, or isoelectric point can vary, but yeah, Zwitter ion form has like no charge, having a both positive and negative charge, but overall it's neutral. And this is like a graph for if they are in the cationic form. Cations means positively charged ion, and anions means negatively charged ion. So negatively charged ion is carboxylate group here, and positively charged ion is amine group here. Okay, and in between cation and anion you have Zwitter ion. Okay, and this Zwitter ion has both positive and negative charge. Okay, okay, so and this is pi, which is isoelectric point. It could be anything between these two. Okay, and pi is basically average of these two pk values. Okay, can I change the pk values, and can you calculate pi for me? Okay, I change pka to 2.5 and pk to 9.5. What's the pi? I'll repeat it once again. pk1 is 2.5 and pk2 is 9.5. What's the pi? 6. How? Average. Make an average. Okay, so pi here is the average of two pk values, pk1 plus pk2 divided by 2. Okay, so if I give you two pk values and I'll ask you to calculate pi, I think you will be able to do that. Okay, cool. Let's go ahead and see the next part, which is I said pi is equal to pk1 plus pk2 divided by 2, which is average isoelectric point. If you replace or if you want to condense two amino acids, you will find a peptide bond. I think this is all covered, right? This all basic information is mostly covered. Based on that, can I label those amino acids and ask you a question about which is what? Real memory testing works here. I just taught you about remembering the names of amino acid based on their R group. Can you name first amino acids we have? Serine. Good answer. Thank you. Second one is glycine. Simplest is H. Okay. Third one is tyrosine. You said phenylalanine hydroxylated forms tyrosine. If I remove that OH, what will be your answer? Phenylalanine. Okay. Third one is alanine. Fourth one is fourth one is fourth one is isoleucine. So valine and isoleucine has one carbon difference. I said valine is inverted V, but you can see with inverted V you have a CH2. Don't miss that. Okay. slightest difference but significant. Okay, so let's go. They have a three letter coding system and one letter coding system. If you don't remember that, go ahead and remember those things. It's easy. You just have few differences. In tryptophan you have some other things. Tyrosine is Y, tryptophan is W, and few other differences, right? So I'm not gonna go and make you remember that. It's easy. Peptides have different functions. They are used as coenzymes, factors, prosthetic groups, and other things. Okay. Uncommon amino acids. Can you find selenocysteine somewhere? Yes, sir. Can you see selenocysteine? What's the difference between selenocysteine and cysteine? Sulfur is replaced by selenium. That's why it's called selenocysteine. What if I replace selenium with oxygen? Yes. If I replace selenium with oxygen, you just learned that. I got that answer from somewhere here. CH2OH. Yeah, but why don't remember? Why can't you remember the other way? Yeah, if I replace sulfur with oxygen, you have serine. But if I replace selenium with oxygen, it is the same, right? CH2OH, which is serine again. Okay. So anyway, let's go ahead and I think we remember. You don't have to remember all those structures because those are advanced biochemistry. If you learn specific reactions where this phosphotyrosine has been used and where is glutamate gamma methyl ester has been used, but no need to remember all those things.